about half an inch. That's all in the whole year.
Ah, okay. Yeah, more like maybe 30 rainfall events this winter here. Haven't or I've lost count. So.
Good.
Yeah, it is nice to see the maps for drought start to become less and less dry because California has been finally getting enough rain.
Do you count atmospheric rivers by numbers or somehow know how many?
I think the number is around 11 using the guidance from the Center for Weather, Water, and Climate. They have a certain magnitude of moisture transport and a certain physical size to an atmospheric river, and that comes up to be about a total of about 11 in that category. So yeah, that is a lot.
What was the normal?
Normally it's probably closer to about maybe a third of that. Yeah.
Bueno, ya está Luisa con nosotros.
We'll start soon, maybe in about a couple of minutes.
Yeah, we invited a few people from the local office, so maybe some of those may join us at some point.
Sure, that's fine.
Yeah.
Looks like I'm the only other person from the San Diego office here, but I'll have to leave at 12:30 so I can get ready to come into work.
Oh, okay. Yeah.
Yeah, I definitely need to take a shower because I just went for a run, literally ending 5 minutes ago.
Just in time for the presentation.
Yeah.
Hi there. We're at the office here in NWS San Diego.
Oh, hey, Adam.
Hey, Adam.
Hola, Luis. Hi.
Hi. How are you?
Good. Yeah, I'm here with Sam and Casey also. So we're all working today in the office.
Hi.
Good. When is the next rainfall event?
Yeah, Sam's doing the forecast. It looks like kind of Monday into Tuesday and Wednesday. So yeah, looking another wet time. Can't get enough of it, I guess. Hopefully a little rain for you down there too, in Ensenada.
I think they had yesterday about 20 millimeters in the weather station there in CSS.
Yeah, that's about 0.8 inches.
0.8?
Yes.
Okay.
Yeah.
Yes.
Okay, cool. Awesome. Well, we'll be on here while we work, so see ya.
Bueno, yo creo que ya podemos empezar. Entonces, Luis, ¿puedes presentar a Ivory?
Sí. Buenos días a todos. Saludos desde la Unidad La Paz de CICESE. Hoy tenemos como ponente a Ivory Small de la Oficina de Pronóstico del Servicio Meteorológico en San Diego, California. Estados Unidos está dividido en 120 oficinas de pronóstico. San Diego es una de ellas. Ahí está Ivory. Él es, su puesto es muy particular, que no lo tenemos en México, en nuestro servicio meteorológico. Él es oficial de ciencia y operaciones. se encarga de vincular las tareas de investigación con la parte operativa de la oficina, interactúa con la comunidad académica y también está a cargo de entrenar a los profesores nuevos en esa oficina. Tiene una experiencia bastante amplia en la parte operativa en la región de California. Entre otras, en 1984 participó en las tareas de pronóstico de los Juegos Olímpicos de Los Ángeles, en Long Beach. Y el día de hoy nos va a platicar sobre ríos atmosféricos, que son fenómenos meteorológicos que tienden a afectar la costa occidental de Estados Unidos y noroeste de México. Este año ha sido bastante activo en ríos atmosféricos. Y pues ya vamos a iniciar con la presentación. Gracias, Ivory, and please, thank you for the seminar today.
Y gracias por invitarme. Luis and I have been friends for a long, long time, sharing weather experiences and occasionally at our office. So this is nice to be able to get on virtually and meet again. So I'll just jump right into it. As you can tell, I'm going to talk about atmospheric river strength, and the name in English for the center there is the Center for Scientific Research and Higher Education of Ensenada, Baja California. Oh, there it is. Okay. Okay, first of all, I'll give you take a look at our map. This is the area that we are responsible for, pretty much right through the center of Southern California there. This, unfortunately, was my view on Wednesday evening. We have a little fuzzy image, but you can see on the far left is the busy eastbound Highway 78. In the middle, that dark area is no cars because it's closed. You can see the center divider separating the bright lights of the eastbound versus the no lights of the westbound. And you can see the line of red and white lights on the far right. I am in that. So 45 minutes of driving through Vista along the 78 because it was closed. And add insult to injury, in the morning, the part that's open now was the eastbound lanes coming into work were closed and the westbound lanes were open. So it was closed going in and closed going home. So fun day down there. Quite a bit of rain. We'll talk about that in a bit. Here's the satellite imagery so you can get an idea of what the atmospheric river looked like that morning. This is about a 2-hour loop. Right before I got there, and you can see there's a whole lot of moisture streaming into the west. Okay, as forecasters, we need to properly determine approximately how many warnings and advisories that we are going to issue on that day to know how many people we need. A chart aimed at looking at these events has been useful for us. I worked with Greg Martin. He's one of our lead forecasters and has been in California many years, looking at how to make this chart useful for forecasting. What I did was some of the key players in looking at atmospheric rivers, I put their names into the chart as almost another way of separating, well, which are the worst categories that you want to be in. And basically, I put a line for an event that occurs based on its intensity. And as you can see at the top right, there are very few events in that category. The bottom in the middle, which says SmallCom, that we get a lot of events in that category. And in there, I have code basically for determining what the parameters are for the event and what the impacts have been for the event. And for example, I probably made this a little bit too small in the red and yellow writing at the bottom, but it tells you the date, which was April 10th, a few years ago, in 2020. Forecasters probably remember that. It's 12Z in the morning. I show the maximum vapor transport and the number of hours that water is being transported. And I've also indicated what type of products in code that we issued, and I can get to that later. And then the other one is going down the line, more code use that I'll explain later. Okay, event magnitude and duration in the study, 250 kilograms meters per second, and event ends if you get a 24-hour drying period, which the IVT is basically less than 250 for 24 hours. We threw in there to look at dynamics using MOS guidance because there can be a large amount of moisture moving in, but if there's no lift, little rain will fall. And here's an example of an event that happened last month with dynamics that is pretty special. As you can see, there's a conveyor belt of moisture over Southern California with this event. And there's nice diffluence with the system, which of course indicates upward motion in those areas where you've got diffluence. Initially, when it's overnight, it shows nice transverse banding over Southern California and a lot of rain with that, but no lightning. But as it moves through, cold air shows up and lightning begins in these green splotches around Los Angeles. So it shows a storm with good lift, good dynamics, and even some thunderstorms. Okay, to get to the MOS guidance, I have to go to get it. And here on the web page, it's pretty easy to get. I start with the Met guidance and select the station. Let's go with San Diego. And let me see. I'm going to want to go with the 12Z version. And then I view the bulletin and it pops right up. The key things I look for is the probability, the amount of precip that is expecting in code, which all the way out to March 20th is not much till you get to a 2. 2 is significant. And look at thunder, T06, 5, which is not significant. 10 is significant when you're talking thunder. So it's got a 5 and a 2. I'll explain more why that's important later. And if you're absolutely insane and you're going to be a wild man, then you can go to the extended guidance and same dates and times and going 12Z, view that bulletin, and that pops it up. And this is where our nightmare may begin again. Looks like looking at the Q12 instead of the Q6 because there are 12-hour blocks and the extended guidance. Notice this 5 under the 132-hour period for Tuesday. It has only been about five times in the last 13 years in the database. So that means 1 to 2 inches is expected at San Diego in that 12-hour period, which is a bad thing. Thunder 16, also it's above 10. These are in percentile. Above 10 percentile, that means you've got lift from convection and you've got a huge QPF. Translation, what you saw on the 15th is probably going to happen again on Tuesday. So you might want to keep that in mind. I will kill that. Oops. Oh yeah, this is just saying the same thing. Here's the Q06 code for precip, where it shows a 1 to 1.5 inches at San Diego, which in most cases, if that was for a forecast for tomorrow, which is more accurate than a forecast for a few days out, that would probably be more than 2 inches in actuality. And for thunder, it's simple. The code is actually the probability of thunder. So easy stuff. Here it is again, showing you the same thing. To calculate this strength of the atmospheric river, we use a proxy. We multiply the precipitable water by the 700 millibar flow and multiply that by 10. In this case, for example, with 1/2 inch of precipitable water at 50 knots, that's about a 750 on your scale. And I'll show you the scale later. Gives you a good rough estimate on that. And then from that 750, we use the MOS guidance. And the way we use the MOS guidance is for those two values we looked at, the Q value and the thunderstorm value, we add a block or 250 to the IVT to raise it up on the chart. In this case, for the 17th, this is on the 17th forecasting for 120 days out at San Diego. It's going for the Q12 of 4, which is pretty nasty. And this was off the 0Z run. I think I looked at the 12Z run just a minute ago, and that one had a 5. So it actually got worse. And here's thunderstorms 11. It said 16 on the 12Z run, which is worse. And that, each of those bumps it up 1 box in the chart. And here's another other stuff to talk about that. But basically what it says is if you see a category 2 or higher in the precip, bump it up. And if you see a 12%, 10% or higher in the thunder, bump it up again. So 2 bumps is usually what we end up with a big storm. So on the chart, this gives you an idea of what the squares look, what the square looks like. And what I did, along with Greg, is we first put all these little lines in here for each atmospheric river event. And like at the second of those little lines, it says FLSCC. That is the that is the flood advisory that has been sent out for at least a piece of a county. And as you see, some of those days is up to 14 of these things with an event. And on the very far right, you can see how much you bumped up based on the MOS guidance. All of the ones in this category in the middle between, in the middle big box was bumped up from the box just below it because the MOS guidance indicated that there was going to be dynamics. So taking that, we then looked at the number of events that had a flood advisory issued. It ends up being the orange text in the middle of the screen, 29%. But notice no flash flood warnings were issued. So that's why there's a 29 and 0 in the middle. 29% of the time flood advisory, 0% of the time we issued a warning. Doesn't mean it didn't happen somewhere, but that was the thinking of the office at the time. Now, if you go far to the right, you see the 63 and the 20 in orange. That one is a combination of the middle of this big box and the next box to the right. In other words, the further right you are, you get 63% chance of being a flood advisory and 20% chance of issuing a flash flood warning. Any questions at this point? Excellent. Again, here's that code. For example, if you look at the one that's fourth column over, says 12 FLSCC, that's 12 parts of counties were given a flood advisory. 3 FFWCC means at least three parts of some county had a flash flood warning issued. And the number of times we had to either write or update the warning for the rivers, for example, San Diego River, was twice. So we had an RFC product out for the River Forecast Center telling us to now worry about the San Diego River in most cases. And as I mentioned before, the next column over under Moss was a 4, again, huge. And under Thunder, the Moss 6-hour T06 was 34, also huge. And the second to last column with the 01 and 01 tells you get one additional box up for each of those two parameters for a total of, on the end, 2 bumps up. All righty. This is saying the same thing in a little bit more text, but here's the original chart with the percentages and left out so you can actually see the numbers. Here again shows you with the numbers in the middle of the box, probability of issuing a flood advisory or warning circled. Again, circled. Okay. So, for example, the 500 to the 749 peak IVT box, which is the middle big box, has a nuisance flooding value of 29%. The box below it has 7% average. So the estimated value at the common side of the boxes is 18. And you can see it's the middle circle on the line there, telling you that those boxes have been averages, and this is approximately what it is. Again, it's a real rough estimate, and it's a work in progress. Here are all just percentages. And here are the percentages added. And some other thoughts. I'll run through this really quickly, but basically, it seems like the atmosphere responds weather resulting in a flood or severe issuance that day for our county. More often than not, a couple of more issuances are involved, especially flood-related events. In other words, if you issue one, you usually issue more than one. And many days, you have clusters of contacts. And it seems like when you have basically a 3-10 day, in other words, your category for precip is a 3, which is pretty big, and a 10 in the chart, which gets you into thunder. It's a pretty impactful day. And when you start getting up to 4 and 20, then it's a all hands on deck kind of day. Pretty busy. Okay, again, the freeway closure deal. We're going to look at that a little bit closer. This was the morning before. It showed a 5 for the precip at Carlsbad, which again is pretty much all hands on deck but the thunder was T12, T6, 0. So it's saying that it's not going to be that convective, but there's going to be a whole lot of water. So, okay, we'll buy that. And it was right. Basically, it says that much rainfall, even in 12 hours, often signals major trail impacts. For example, freeway impacts if around Carlsbad, or travel and or shopping because it floods the mall impacts due to near or above flood stage at downtown San Diego. So yeah, whenever you want to see, ever you see a 5, be prepared to be very busy. Again, the thunder 0 didn't matter. Oh, and that's also, this is for San Diego. Notice they had a 5 and a 0. And pretty wet down there as well. Okay, just looking at the March 15th case, the bottom of the chart has the B original without bumping it up for Moss. And then the second one has the B dynamic, which is a bump up for Moss. Basically means that the 81% flood advisory and 34% of the time flash flood warning is issued for an event that adds up like this. And let's see, nothing else good there. Okay, remember, warnings are based on a decision of the forecaster. We didn't do this on actual events. We did the chart based on the products that were issued by the forecaster. So the forecaster uses the radar, and if you want to use the chart for upcoming events, you find out the maximum precipitable water for the event times and the 700 millibar wind speed to get the maximum flux coming through. And you note how long that flux remains above 250 units, which is kilogram meters per second. And then you look at the Moss guidance and do the appropriate bumping based on the magnitude of your Moss guidance. And some things to throw in there, we don't look at the angle of incidence. In other words, if it's coming from the northwest or coming from the west or coming from the south, we don't look at that stuff, at least not yet. We assume that the 700 millibar model guidance in the integrated water paper is correct, which is not always a great assumption. And the model Moss guidance forecast for T06 and Q06 are correct. And again, a larger data set will make the percentages more representative. And okay, this is looking at the windstorm with some of these huge, this is more of a wind impact or wind driven sort of atmospheric river on as well on the 22nd, showed 101 mile an hour wind gust on the backside of our mountains. And if we start seeing stuff over 100 on the backside of our mountains, somebody's going to get a problem. And in this case, there was, I think, 50 power poles that were knocked down a little further south than Burns Canyon, but that's probably another place where the wave surfaced. And notice it was, oops, I did forget something. Let us view the satellite imagery. You can see the cold front coming down, a lot of cold air behind it. And it's about the time that the winds peaked to Burns Canyon around 4 a.m. in the morning. Okay, burst of precip with the front. A change in the temperature dropping into from the mid 40s to the mid 20s. Dew Point's freaking out because it's a little mountain wave action going on in there as well. So it's having a tough time. And here's the relative humidity, which went up for a little while with after the precip and then started heading back down. And this you want to probably take a good look at. I threw this in real quick at the end, so I got the date wrong, but that should be March 21st, 2023, which is coming up here, the storm that's coming up here. So I wanted to make sure I got that into this show. So I might have an error or two that I had to check, but I think it's important. The 250 millibar winds in the upper left indicates what I tend to call a super jet. When you get 177 knots, you're like 205 miles an hour. So yeah, that's a nasty jet heading towards us. 700 millibar winds, 57, 850, 35, and a precipitable water around an inch. That, using the equation, gives you 570 maximum IVT without bumping, which is pretty good. The 411% in the MOS guidance means you go up 2 boxes, puts the value at around 1,000 on the chart. Actually, that puts you 5, 6, 7, 8, 9, 10. Yeah, above 1,000. It was 72, between 72-hour and 114-hour forecast on the guidance, which is about 42 hours long. It's a pretty long event. And 57, the 700 millibar wind times about 1.1 on the precipitable water is 627 max IVT without bumping yet. So it's going to really push it up. Adjusted, that's from 627 plus 500 is 1127. So effectively, it's over 1,000 for the integrated water vapor transport. That's the impact of this event. Oops. And for 42 hours. Looks similar to the March 15th event. And again, on the scale, you can see up near the top, the second to highest box, that's where this event is for, again, Tuesday, March 21st. And nearly 100% of the time you get an urban, and over 70% of the time you issue a warning. We shall indeed see. And that's all the yakking that I've got to say here. Hopefully everybody's still awake and can answer a question or two.
Emilio, ¿tú ves las preguntas? Ivory, can you hear me?
Yeah, I hear you. You hear me?
Hola, Alina.
Sí,
¿Cómo empezamos las preguntas? Primero, ¿quién iría?
sí, los que gusten, que tengan preguntas, pueden abrir su micrófono, primero Webex y después las redes sociales.
Correcto, Luis. No sé si alguno habrá levantado la mano normalmente en participantes. O pregunta, ¿quién tiene alguna pregunta en Webex y después en redes sociales?
Yo quisiera preguntar algo, ¿está bien?
Sí, pero también tú atiende los que quieran preguntar.
Muy bien. Ivory.
Yes.
I have seen when there's an atmospheric river in that area, there are airplanes, U.S. Air Force airplane going to the Pacific, and sometimes another airplane coming from Hawaii. How helpful are they to your forecast information, or as a data set that can be used in your forecasts?
Yeah, the key thing about the aircraft is it gets assimilated into the model data, which will improve also the model guidance to get us the numbers that are more accurate for making these atmospheric river predictions. So yeah, that they have seen to be useful, and I'm pretty sure they're going to come up with research comparing the two. Kind of like what they do with the hurricane hunters, send them out to see what's really going on with the hurricane. So yeah, I'm looking forward to their papers and additional information on those flights.
Do you release more soundings in San Diego or other places in California when there's a river coming, or it's not that required?
Yes, we typically issue, at least the people from Center for Weather, Water, and Climate, they issue they do soundings at Seven Oaks Dam, which is in the San Bernardino Mountains. And I think they'll do something along the coast, probably closer to La Jolla. And then also they'll do soundings up at the Bodega Bay area up near San Francisco. It's one of their favorite spots to look at. The Russian River, which floods fairly frequently and used to be one of my old fishing spots when I was up there in Northern California before coming to UCLA. So it's a good thing to get those soundings up. And like I said, I did the sounding launches at UCLA in the morning, and it is an excellent way to figure out what's going on, because right out the bat, we have the inversion strength, and you kind of get an idea what the temperature is going to be and that kind of thing. So yeah, they're doing that along with their drop sound. They're doing soundings with the aircraft too, in the actual storms. So there is a lot of sounding information.
Yes, thank you. Alejandro Hinojosa creo que tiene la mano.
Can you hear me?
Yes.
Okay. Hi, Ivory. Thanks for your presentation. I see the San Diego forecasts are very close to what happens in Ensenada. So how do you see this year? It's been an anomalous year. It's mainly because the atmospheric rivers. How do you compare to other years, the precipitation?
Yeah, this looks a lot like what happened during a really good El Nino year, where you get low latitude storms coming along into the area south of a unusually strong high pressure area. And until we can break that pattern, there's always going to be the opportunity for those storms to come directly into Southern California from the west. And unfortunately, the last big El Nino that I remember, it rained with big lows all the way up to the middle of May. So I'm hoping that's not the case, but at least for a while, it is the case.
So you're forecasting another storm for next Tuesday, you said?
That's what the models is telling me. I haven't looked at it as close as I'd like to see how it compares to other guidance models, that kind of thing in the long range. But yeah, this one looks pretty solid. Right around Tuesday.
Okay, thank you, Ivory.
Los que gusten hacer preguntas pueden abrir su micrófono y cámara.
Teresa Cavazo sigue. Adelante, Teresa.
Sí, estoy... ¿Me escuchan?
Sí, te escuchamos.
Muy bien. Hi, Ivory. Very interesting, your talk. My question is a little bit similar to that of Alejandro. I remember the 2017 year, which was a La Niña year. We also had many atmospheric rivers. But this year is very different from that, from the 2017. What do you think is the major difference in related with circulation, anomalous circulation?
Yeah, I think sometimes, even when we're talking El Nino or La Nina, the actual impact of the phenomena is overpowered by what the atmosphere has decided to do that year. And I think that, for example, this year it says, I'm feeling El Nino-ish. And so it gives us this sort of classic El Nino east-west pattern under the ridge. And the one in 2017, that one, for some reason, could not get the lows to cut under as well as this year does. And I'm thinking that it might have something to do with what's going on in the Arctic. There may be some changes up in the Arctic that may be affecting what goes on down here with, you know, a little bit of potential warming going on up there, that kind of thing. So who knows, we may have to rewrite our books.
Yes, thank you.
Bueno, ¿alguien más? Una pregunta, a ver, José Gómez, adelante.
Hi, Ivory. Thank you very much for your talk. Very, very interesting. It's good to know that another event of raining is coming. Ivory, I would like to know how the atmospheric rivers are generated. Which one is his dynamics? Why they move in this way, something like that, please?
Oh, yeah. What happens a lot of times is to get the real good atmospheric rivers, we need a huge low in the Gulf of Alaska and storms rotating around that low with these, quote, super jets behind them. In other words, you get up around 200 miles an hour, somebody's going to get a strong atmospheric river. And when we get that set up, we get multiple atmospheric rivers a lot of times. And that kind of a pattern is something we probably need more of so we can get our infrastructure ready to be able to do something with all the water that we get, as opposed to forecasting people to evacuate. You know, we can just store the water or something like that. So yeah, that's what's been kind of the feast or famine type of weather pattern that Southern California has. It depended on whether or not you start seeing things like at 500 millibars, things pretty close to about say 520 or so. Then you got the possibility to get strong atmospheric rivers coming around the low.
Thank you very much, Ivory.
Yeah.
Bueno, creo que ya no tenemos más preguntas por aquí, pero en redes, Alina.
A ver, en redes sociales, felicitaciones al doctor Ivory. Hasta ahorita, solamente.
Bueno, entonces, ¿alguien más tiene alguna pregunta para realizar? Steven Bullock, por favor, adelante.
Good afternoon. I'm not a meteorologist or climatologist. I don't understand very much of these things, but as a plant ecologist, I'm very interested in the results. One thing that struck me in particular when you were mentioning thunder, I grew up in the Los Angeles area, and I can't remember thunder or lightning until we had some very anomalous storm in the summer of some year, but maybe once in all the time I was growing up, there was thunder or lightning west of Los Angeles. And in recent years, it hasn't been so rare. In the wintertime, I was really surprised when it first occurred in the wintertime here. Is that something that's directly associated with the atmospheric rivers?
A lot of times the thunder does show up with the atmospheric rivers. In most cases, we have more of a upper level, low pressure area with good lift near the middle and at the front to be able to get thunder. And this far south, it can be pretty rare. It can stop at the Bay Area, and this far south, the lift has weakened quite a bit, and the center of the storm can warm up quite a bit. So without that good lift and that good contrast in temperature from the mid-levels to the ocean surface, it makes it tough to be able to generate thunderstorms. But yeah, during the periods that we get like these good atmospheric rivers that come through the area, yeah, we can get thunder every other storm.
Thank you.
Ok, ¿alguna pregunta más? Pues no. Ok, thank you, Dr. Ivory.
Oh, wow, I'm more than happy to present you. And if you need any presentations in the future, just give me an email and we'll make that happen.
Ok, thank you. Luis, ¿quieres despedir a Ivory, por favor?
Thank you, Ivory, for your presentation. And we hope to see you again for more updates on what the atmospheric rivers are doing to your area and to the Ensenada area where many of the audience is located now.
Okay, yeah, we'll do.
Well,
Ivory.
Have a good weekend.
Take care.
Thank you.
Bye.
Bye.
Bye, Mr. Ivory.
All right, have a good weekend.
You too.
Goodbye.
Bye.
Gracias, Alina. Nos vemos después.
Hasta luego, doctor Farfán.
Feliz fin de semana.
Igualmente a todos.